Bismillah ar-Rahman ar-Rahim. Lecture 2, we will talk about the basic laws of electrical circuits. We will begin our discussion about Ohm's law, then we will go further for Kirchhoff's current law and Kirchhoff's voltage law. So first of all, we will talk about Ohm's law. Ohm's law, it is the most basic law in electrical circuits. It states that the voltage across a resistor is directly proportional to the current flowing through the resistor at constant temperature. So we will write it down. وأنا أشد على constant temperature. The sample for resistor is like that. Here is the resistance of the electric wire, of the metal wire, voltage across this resistor, and the current is flowing through this resistor. And the relation that describes those three variables are as follows. V is directly proportional to the current, and the proportionality constant is R multiply I. The resistance. What is a resistor? A resistor is the opposition to the current flow. If we apply a voltage across a conducting wire, say this is a copper, and I apply a potential difference across this wire, a current will flow, and this current is determined by its resistance, because the resistance of the copper is opposing the flow of current or the flow of charges through that wires. So what is the characteristic of a resistance in a certain element? For example, if we have a cylindrical metal with certain cross-sectional area, this is the area, and this is the length of the wire, and this metal has a resistivity which is determined from a table. The resistivity which is measured in ohm per meter. For silver it is 1.64 multiplied 10 to the power minus 8 ohm per meter. Then the copper has a resistivity of 1.72 multiplied 10 to the power minus 8 ohm per meter. Then gold is in the third place. The best conductor is silver, then copper, and the third one is gold, which has a resistivity of 2.45 multiplied 10 to the power minus 8 ohm لكل متر. And أربعة لو نأخذ insulator, which is glass. Glass is a good insulator. It has 1 multiplied 10 to the power 12 ohm لكل متر. يعني في كل متر قيمة مقاومة هذه المادة لمرور التيار هي 1 تيرا اوم. تيرا اللي هي 10 أس 12، وهذا يعتبر قيمة عالية جدا. طبعا هذه القيم تتأثر بدرجات الحرارة، وإذا كان المعدن كذلك a combination of 3 or 2 or more elements. So for this metal, the resistance is equal to rho, which is the resistivity, multiplied by the length over the area. And we can observe that if the length of the wire increased, its resistance also increased. And if the cross-sectional area is increased, its resistance will decrease. And this is a constant, it will not affect much. This equation, which is, let's say it, equation 1, can be graphed in this manner. If this is the current in ampere, and this is the voltage in volt, the resistance, there will be a linear relationship between the two of them, and this will be the resistance. So the resistance is the voltage divided by the current. And it is measured in ohm. It is named in the honor of ohm. What is the effect of temperature on metals? Metals are good conductors. So pure metals increases as temperature increase, with a linear relationship. If we have a certain element has a resistance R0 at 0 degrees Celsius, air temperature in degrees Celsius, then at 100 degrees Celsius the temperature will rise in this manner. And why the resistance increase? We can see that if we increase the temperature of a metal, its length will increase, causing the resistance to increase. What is the effect of temperature on insulators and carbons? Carbon and insulators resistance will decrease as temperature increases. But what if we have an alloy metals? For alloys, R increases with unknown rate, or sometimes it doesn't change. It does not change when the temperature is changing. For some certain, just for a certain domain. This is a very important term, which is the resistance temperature coefficient, RTD. If we have this relationship, let's say this is theta and this is 0 degrees Celsius. This is the temperature in degrees Celsius. This is R node, and this is unknown resistance R theta. If we want to find the slope is R theta, this one, minus the final minus the initial, R 0, over theta minus 0 degree Celsius over the temperature. This gives us the slope. The slope is the rate at which the resistance change with respect to change in temperature. So the temperature coefficient alpha 0 is equal to slope over the initial resistance. The slope is R theta minus R 0 over theta minus 0 over R 0. This will give us R theta minus R 0 over theta R 0. And we have here ohm, and here is ohm degree Celsius. So the unit of alpha, temperature coefficient, is per degree Celsius. So from this equation we can find the resistance at any temperature, which is R theta minus R 0 equal to alpha multiplied by theta R 0. So R theta will equal to alpha theta R 0 plus R 0. So R theta at any temperature means the resistance at any temperature equal to, taking R 0 as a factor, so remains 1 plus alpha